Yum, yum!
Greg here from Pixel Fondue. Hope you are doing well. This video is going to cover Octane 2021 in some depth. It was just released a couple weeks ago after what seemed like a pretty long beta period. And yeah, my host program is MODO, so if you don't use MODO, no big deal. I'll be covering all the features, or pretty much all the features in the 2021 release, except going into depth in the color processing and some of the volume stuff, which will have to be separate videos because this one got pretty long, but you can follow along even if you don't use MODO, and I think get something out of this video. Right off the bat, when we just talk about the ray tracing updates, they've essentially updated any ray tracing algorithm in the program to make use of the RTX cores. Obviously, the shading did and some of the geometry intersections and stuff like that. But even things like rounded edge shading, if I plug this in here, you'll see some rounded edges on these cubes now. That requires ray tracing to get that effect, and that's been accelerated via RTX, or we can use the RTX cores now. Same thing with something like the dirt shader. Plug this guy in, that sort of ambient occlusion look, that requires ray tracing. And again, that's now being accelerated through that RTX pipeline. So it's nice to see them do that. This new curvature texture, which I'll show in depth later, same thing, it uses RTX. So it's good to see OTOY do this, and this is going to be a theme throughout this video, is they really do seem to kind of go back and update existing features with each new release, where a lot of companies, they release something like edge rounding, and it just stays there for 10 years. They don't touch it. So it's nice to see them touch on every existing feature, and if they can gain some more speed by taking advantage of RTX cores, and then they do it, which is good because we spend a lot of money on these cards, and we definitely want these images to come out as fast as possible. So next, let's take a look at some of the new OSL textures. There's a bunch of them, and some of them are really cool. One of the things that I'm really happy to see in Octane 2021 is the inclusion of a lot of OSL texture nodes and utility nodes, and there's a lot. So if I go over here to my textures, there's quite a few new procedural things, which I'll go over them, a number of them at least. And there's some new converters here, just some utility nodes, and some new geometric nodes like the curvature node. And there's even some new mapping nodes like chaos texture, which is pretty cool. We'll take a look at that. And some additional operators, like all these math operators here. If we take a look at these, there's just a bunch of math operators if you want to do some stuff in the schematic. And there's also some other utility nodes, some channel nodes down here at the bottom. So again, a lot of these I think were available before as OSL nodes, but they may have just been code they had to load into an OSL script editor and run. It wasn't super user friendly. I also see OSL as something that's going to get sort of bigger over time. There'll be more sort of community generated texture nodes, both utility nodes and actual full-blown procedural nodes. And there's some pretty cool ones in there. I'm just going to jump over to After Effects real quick. I rendered some of this stuff out. I'm not going to go over everything like I said, but let's take a look at some of these. And so here's a couple of them. We've got a chainmail one on the left and this sort of, colored squared one on the right. Again, these are some probably really simple OSL ones, but as you can see later on, they get actually fairly complex. There's a fractal one. Again, probably won't use these very much or at all. Some of these tiling ones you may use, a triangle tile or the scale tile there, or there's a hexagon tile. There's also some of these like glowing circle and these gradient ones actually are useful for emitters. You can just map these to a plane, and here you get that sort of light ring effect. You just map it to an emitter. Here we've got a number of different gradients. There's like a linear gradient. We've got a polygonal gradient, like for area lights. We've got these spiral gradients and radial gradients. This Hageslag material is also used as a light emitter node. So you can always use all of these on planes or circles for lights. And then there's some cool procedural ones like this purple stripe one and this combustible one, which is animatable over time. And I really love these wavy colors and these paint colors. In fact, we'll just jump back into MODO and explore these a little more. But I think this is these two in particular are where I see like the future of OSL going. Some really cool stuff there. These new OSL procedural effect textures really actually deserve a closer look. So just got a glossy material on my shader ball here, and the procedural effects texture is plugged in, and you can actually pick the type of effect you want from a drop down. Here we've got wavy colors. And here you can see kind of where I think the more complex OSL shaders are going to come into their own. And as time goes on, these open shading language, I think more and more of these will sort of make their way out into the public domain, and hopefully they'll be integrated into Octane, just from a drop down, so we don't have to like start copying and pasting code and stuff like that. But they're really cool. They've got this time channel here, so I can just click and drag, and just real time, I'm just watching this thing swirling around in the viewport. It's great, super fast feedback, and it's very artist friendly. I can even remap it into a gradient. So we've got a gradient right here, and I've got a sort of fiery colors on there. And if I plug that into the diffuse. I've remapped that swirly sort of painty look with this gradient, and you can just, mind starts to race. You think you can, understand how you can get some really cool effects here. This also has a really nice one called paint colors, which I think is probably my favorite. So again, this sort of swirly paint colors. I can adjust, the scale down here and bring in some colors over here on the edge, and I can adjust the time here as well, and so we get this sort of cool look. And if you want to take it further, you can even get a sort of a car paint look by using this new texture called flakes. So this is just sort of metallic flakes you'll see in a car paint or metallic car paint. You can grab that. If I put that into the fuse channel, you kind of recognize those as normal channel colors. So that really belongs in the normal channel, and it's going to sort of bounce light in different directions, just like little tiny flakes of metal would if they were in your car paint or suspended in your car paint there. So what I need to do is take this guy and just make them a lot smaller, obviously. So we'll do 1%, and now you can see these tiny little flakes in there, sort of, little glints of light. You can adjust stuff here. I could knock the flake size down a little bit and sort of more space between them. And there's some flake size variance and a blend factor on there as well. So you can do something like no flakes, I think is maybe 1, and this is kind of clean, or you can go all the way down to like 0.1, and so the flakes are really, really prominent. So pretty cool. What else we got? Let me just transform this into a specular material really quick, and unhook my flakes, and unhook my, get my procedural textures out of the way a little bit. And there is an iridescent texture as well. So let me just hook that up to reflection maybe. Let me just unhook reflection and select it so I can hook it up automatically. And I'll just go to texture and bring in my iridescent texture, which is somewhere in here, iridescent. And there you go, you get sort of an iridescent look. In fact, I should probably go to thin wall to get that sort of iridescent bubble look. Probably put that on transmission as well to sort of enhance it a little bit more. But you can see you could do with it, right? Pretty cool, pretty interesting look there. So there's definitely some interesting new procedural textures in here. In fact, this list is getting pretty long. And I'm excited to see where these new OSL textures are going to go in the future. 2021 also gives us the curvature texture. So this is sort of a new and useful thing, similar to the dirt texture. Let me just plug it in here to the diffuse color of this white glossy material. And you can see it's computing, it's using the normals of the surface to compute the curvature, and it's outputting a black and white image essentially, or black and white values. I can change the mode to concavity from convexity. There's some other channels here like radius and tolerance to sort of help things out. So you're not going to get drastic effects on this, but you can change it up a little bit, and you can see some differences here. So let me just maybe turn this back to 6.6 or so. And you can see the scales, the sort of different curvature on the scales there. Now, if I look at the dirt map, let me just do a little bit of a render region through here and plug in the dirt texture, which we've had for quite a long time. But that's also, I guess, RTX enabled on this new version. And you can see it's just a little more uniform, right? So, crevices are going to get this darker sort of dirt look as sort of an ambient occlusion look. But it's different than what you get with the curvature node. So different look for it, and you're going to use it, something like an input to a gradient. So if I input it to a gradient here, and I use this gradient to control the mix amount of a mix texture, and on that mix texture, I've got a gold metallic material. Let me just sort of undo this render region here. And our glossy, instead of white, what I'll do is I'll plug the dirt texture into another gradient, sort of this dirty brown gradient, green brown gradient, and plug that in here. And then when I look at the mix texture and plug that in to my Octane override here to get the full effect, you'll see where this is useful, right? It's sort of that grungy gold look based on curvature. So you've got some stuff in here. And actually it gives a much more random look, in my opinion, a much more realistic sort of random look than just the dirt texture did. So this is actually a combination of dirt and curvature, where dirt is giving brown and green depending on the sort of ambient occlusion sort of dirt calculation. But yeah, I think it's pretty cool, the curvature calculation, and I'm guessing it's going to get quite a bit of use. It's so nice to be able to compute these things via real-time ray tracing rather than having to bake this stuff out and just being stuck with what you've got. So These just compute so fast now. Again, you can kind of see the future of where OTOY is going. It's just all real time. Here I could just zoom in a little bit here and take an even closer look at this effect on the head. So yeah, cool. 2021 also has something called a chaos texture. This is great for texture bombing a surface with an image. By texture bombing, I mean dropping a bunch of different scales and rotations and blendings of the same image over and over on top of a surface. This is useful for texture mapping or graffiti or something like that. Here I've got a bloody handprint, right? And so this chaos texture will take any texture as an input. So I'm going to put this image as an input. And then I'm going to replace that UV mapped hand with the chaos texture hand. Now when you first plug it in, it actually takes a moment to compute. And after it computes whatever it is, whatever math it's doing, you're able to manipulate it in real time. So here it's done computing, and you can look at the channels we have to play with. You can see it's just sort of, bombed this handprint all over here. And so I can adjust the scale of the texture like that. I can adjust the coverage. You can see it sort of moving around there. You just adjust the scale. I can adjust turn on rotation, and it'll rotate those little hand images around and change the rotation seed. So yeah, you're just sort of bombing your surface with a particular image, like a decal would be a good source. And yeah, getting a lot of variation on there. And again, I think this would be good for landscapes and things like that. The smooth shadow terminator, this sort of faceting you see here in a low poly object, this sometimes crops up. This is actually an issue with all renderers. They'll have some sort of fix for it. Octane 2021 now has a fix for it. You'll see it in pretty much every material. There's just a little checkbox for smooth shadow terminator. Let me just pull this out. Smooth shadow terminator, and you see the faceting is there, and then when I click this on, it's no longer there. And apparently there's a slight performance hit, but I'm sure it's not much. And honestly, this isn't a problem you see very often, but it was kind of hard to solve if you did actually bump into it. So nice to know there's a fix now. There's a couple new projections in Octane 2021, or different ways to map your texture other than like UV or box or planar. There's a distorted mesh UV, which looks really interesting. It seems like you should be able to, it's sort of a UV mapping where you could then distort it with a texture, like maybe a noise texture or something like that. So you get a UV mapped image and you can distort it with a noise texture. I have not been able to figure out how that works, unfortunately. But we do have a matte cap projection, which is useful because matte caps are kind of cool and they don't really work with regular projections. So if I look over here at my matte caps and I grab this, maybe this pink one, and grab one of these sort of ZBrushy looking red ones here, I'll just load it in and then go to my images and grab these two guys and pull them in the schematic. Now if I look at this like bubblegum one and put it on the file name here, you see it's just trying to UV map this image and it doesn't look right. But if I change, right now I have the UV projection, if I change that to matte cap projection, now it looks like a matte cap. So we can use matte caps in our rendered Octane scenes now, which is pretty cool. So let me just get this red wax one here as well. Get the file name channel up here and plug it in. And there's the sort of ZBrushy looking red wax matte cap rendered ray traced in Octane, which is pretty cool. Octane 2021 has some new BRDF shading models and its materials. So just looking at the schematic here, I've got this specular material on this dragon. And you look over here under the BRDF model, we've got a couple new ones. We always had Octane, we've got Beckman and GGX. Now we have a GGX energy preserving, which I think is actually significant, and an STD model, which I don't think is super significant. It allows you to adjust the spread of one of the specular lobes, and that attribute becomes active if you use the STD for like a metallic texture. But it's a really subtle change, so unless you're super tweaky, I'm not sure you're going to really using that much. But if you look over here, just jump over here to After Effects. Now I rendered out some animations of the roughness going from 0, like these two specular materials, so perfectly smooth, to 1, completely rough. And it's a pretty startling difference in that the GGX energy preserving model really looks a lot more realistic. So if I just drag my little timeline here and we see going from 0 to 1 in roughness, the GGX model will get pretty dark and obviously not realistic, while the GGX energy preserving model maintains the correct brightness and just looks a lot more real. Now, I only rendered these with 512 samples, so the denoising kicks in and it's a little chunky there. But if you look at this, again, if I just sort of drag through here, once I get to around, I don't know, 50% roughness, this starts to lose brightness, and this looks more realistic. And you've probably seen this effect before. So you got, a nice looking frosted glass over here. this just doesn't look real. So I do think it's fairly significant. And it's a little less significant, but still noticeable with metallics. So again, here we go with gold, roughness of 0, perfectly smooth. As I drag the time slider here, getting towards a roughness of 1. And again, this goes dark while the GGX energy preserving maintains the brightness. So in MODOs, you're not typically going to get this rough, right? You might actually, you know, that's right around here at 70.75 roughness. Yeah, that's getting fairly dark. And this could be like a really, really matte gold or a finely, you know, sort of a matte surface, metallic matte surface. So, you know, actually, I would tend to choose GGX energy preserving over GGX pretty much every time now. Octane 2021 also updates their hair shader. Now, I like it that they're continually revisiting existing shaders and other aspects of the program, like the BRDF models, and updating them and making them better. I think that's fantastic. And Octane actually already has a really good hair shader, and there's a video on Pixel Fondue I did about a year ago going over in depth. Now, if you don't know, you can do this either through albedo or melanin modes. Albedo is nice if you want to just pick a color or do something like dyed hair. So I can pick like a sort of a pinky color like this, and you can make, you know, different colored dyes or whatever for hair. I'll just do render region to speed it up. But I really like the melanin mode, where you go over to melanin and then you just dial in the amount of melanin and pheomelanin, I believe that's how it's pronounced, in the actual hair strands. And so you can get some really cool looking hair here. So there's, you know, a lot of melanin is going to give you a brunette, just a little bit of melanin, or maybe a little more than that is going to be more of a blonde. And like that just looks really cool, really realistic. I'm just rendering curves here in MODO. These are just renderable curves, about a little less than a millimeter in width. And you can get, if you're right in the middle, you can get sort of a reddish color, especially if you bump up this pheomelanin channel like this. You get sort of a natural reddish look as well. Really cool. Now, Octane 2021 did add a random roughness or attribute here. And I've got that cranked up to 1. I got to be honest, I cannot tell the difference between 0 and 1. So maybe my lighting isn't bringing that out. I'm just using an HDR. Perhaps I should have some area lights in here. It's nice that they're, you know, continuing to adjust it, and I'm sure it has some sort of effect. I'm just not seeing it. If I go over here to After Effects, I'm just, you know, this is the random roughness sort of red strand, and if I bring in the red strand that just has sort of standard roughness, you know, and flip between them, there's just there's no difference at all that I can see. Again, maybe that's user error, and so I'm sure that there's something in there that I'm missing. I like that they're putting in there, but man, the hair just looks pretty sweet in Octane. I just love that. Octane 2021 also has surface clipping, so this is often called render booleans and other packages. And so let's take a look at how it works. It's actually a pretty important feature. And it's done at the material level. So I've got my 2 objects here, and I've got material on my ball. So I'll just select that and go over to the schematic. And right now it's just this red glossy material, right? But we're going to change that to a clipping material. So add new material, add a clipping material, and just plug that in, and it gets rid of that glossy one. And now I'm going to move the ball over and sort of intersect it. And you see what happens here. I'm just going to push in. You see it's now clipping into my cube. And I've actually set up a bit of a render composite here, and I'll show you how to do this later in the video. But here's a wireframe view, and here's the beauty view, and here's a composite of of those different outputs. So you can kind of see what's happening here, right? So it's actually just chopping in. You get polygons on the inside just like that. And there's a few controls on it. So if I go back over to the schematic here, and take a look at this, there is something called an intersection channel. This allows you to pipe in a material, and so I could pipe a material into the intersection channel, and I'll just pipe in this, you know, red plastic material we had been using previously, and it'll fill the clip section with that material. So I'll just plug it into the intersection, and there you go. I'm gonna go back to the beauty pass so you can see that how that looks, and there it is. So now that material is you know, just, you know, filling the intersected, or the new polygons being generated by the clipping in there. And it's super fast. Octane is just so fast. And I believe all of this is RTX accelerated as well if you have an RTX card. There's a couple other controls there. So I can I'll turn on a toroid up here. We'll just sort of move this down and take a look at let's go back to the ball materials. So let me go back to my schematic. there's something on here called priority. Actually, let me talk about the custom ray epsilon first. So if you look at your standard just Octane render settings in the kernel here, you'll see a setting called ray epsilon set at 100 nanometers. That's really just a precision setting, right? And it comes into play when you really have really small objects or things really close to each other and it's calculating refractions and stuff like that. It also comes in handy with surface clipping. So surface clipping, sometimes you're using really small objects or their surfaces really close to each other. And if you need something, you know, with more precision than 100 nanometers, you can just click that custom ray epsilon enabled and then say reduce this down to 10 and you'll get, you know, sort of more precise cutting if you need it. If you're seeing errors in your cutting, you can do that to fix it. So I'll just turn that off. The other one here is priority. So let's say I set my priority, well, just keep it at 100 because that's the default. And let's say I want my sphere to intersect with my cube, but not my torus. So I move this right up here. It's now intersecting with both of them. But if I go to my torus material and look at that, whoops, sorry, the torus material, there is a setting now in all these materials called priority. So they usually default to 0 and they will always default to 0. And you can see that, you know, that's clipping. But if I bump this up to equal or above the priority setting of the clipping material, let's put it at 100, it's no longer going to clip. So you can determine on a material by material basis which materials will be clipped by the clipping object and which won't be. So that's also very useful. So let's take a look at some real world examples of this real quick. So this is the Apple Pro XDR monitor, or an approximation of it. I actually used this model to demonstrate render booleans in MODO 15's empath. And so I'm going to show it here again in Octane. There's a couple different layers of render booleans going on here. So if I hide these back panels here, and let me just go to perspective view, and pop on these first set of cutters, you see these red parts right here. They're cutting these initial holes into the back. And then if I turn that panel back on, so we'll just turn that back panel back on, they're being hidden. And then if I turn on these new sets of cutters, these circles, they cut into that outside panel, giving you this sort of nested effect of holes cut into the XDR monitor, which, I can't remember what the name, the fear of holes is called, but if you have that, I don't get one of these monitors because they're a little bit creepy. Also, the back parts of the monitor are done with the render boolean as well. So I turn on these cutters right here. This is done with the render boolean, right? So I didn't have to model it, just chopped into it. And then here's where I use that priority setting where I've got this cutter here. Let me just turn it back off. There is actually whoops, center cutter, this one. So there's actually a piece of geometry here, right? This little circle. I don't want to chop that away. Let me hide it. I just want to chop a hole there. So here you see the hole. And so I use that priority setting. So if I turn my crossbar back on and I look at that material here, wherever that might be, the crossbar, and go to the schematic, you'll see it has that render priority up to 100. So that render, the clipping material is ignoring it. So it doesn't get chopped away. It's there, but the hole behind it gets chopped away. So this is a fairly simple example, but it's pretty cool how you can create something pretty complex like this just with render booleans without having to go in there and chop up your polygons with some, what are going to be pretty slow Boolean operations. I mean, this is super fast. So I wanted to push this clipping concept a little bit. And I got this cute little T-Rex here, baby T-Rex, off of Sketchfab by an artist named Anivas, which I'll credit in the description below. And there's a couple of layers going on here. So we've got the skeleton. And here we have the egg albium, I believe it's called. And that has just a specular material with a little bit of roughness and an absorption medium. So you can see like the claws and the head here that are closer to the camera aren't quite as obscured as the style, like the back leg here that's farther away. So there's some absorption going on that specular material. So it's a little bit more of a complex material. And then on top of that, we've got the egg shell. Now the shell, if I just let me just go to perspective and wireframe mode here and maybe just sort of isolate my shell so we can take a look at it. And you can see that the shell has, I hope you can see that, it has thickness. There's two different loops here, right? There's an inner surface and an outer surface, and it's about 1 millimeter or so thick. And it's important to have that. If you don't have thickness, and you cut into this shell, you're just going to get shell material on the inside, kind of like you're sectioning a rock or something. But with that thickness, I can take this cutter object here, which has the clipping material on it, and start pushing in. And you can see that I'm cutting in here. At this point, the dinosaur skeleton and the albium both have their priorities set at 100, so they're not being clipped. It's just the shell being clipped, and you can see the shell material right here with that thickness, right? And you can also see a bit of a gap between the two. You see a little bit of a gap between the shell material and the albium. You need that gap. Now, maybe I made the gap a little too big here. You can shorten it down, and that's where the ray epsilon comes in, that setting where if you need more precision, you start getting errors, you can lower that setting so the rays don't get discarded in that little gap there. But it's working pretty well. I can see a little bit of an error coming on here, maybe, or it seems like an error with the head. So if I pull back a little bit, if I'm not intersecting the albium, it looks good. But if I start intersecting it, even though its priority is set to 0, it seems like there's some errors going on there. If I pull this out and I go to my albium material, which is, yep, right there, and I set the priority of the clipping back to 0, so it gets clipped, go like that, hide my schematic, and move this back in. Now I'm clipping both the shell and the albium, and it seems to be doing it correctly. So the dinosaur's not being clipped, the fluid inside is, and the shell is. Although it seems like maybe the absorption's a little bit off. It seems like it's absorbing a little more now, or the absorption seems to be not having a proper effect. Just to note, I do have nested dielectrics on. That seems like that should be on in a case like this, and turning it off doesn't do anything. So it does seem like there's a few things that aren't, quite working as you'd expect them, or, being physically accurate. Again, if I turn off my shell here and turn off my cutter, I should have this absorption sort of looking effect going on here, where the back legs are darker, they're deeper into this yellow semi-transparent liquid, where the skull and these claws are less obscured by the absorption. But if I turn my cutter back on, I'm sort of losing that effect, right? Everything's just, maybe just actually it's still there. It just doesn't seem right. I guess the effect would change because there's less material in front between the camera and the clip. So I don't know. Maybe it is correct. I don't know. That may actually be right. So I take that back. And you got the shell clipping. Anyway, so it's a pretty cool effect, and you can use it for all kinds of reveals and things like that. So that's the new clipping material. Octane 2021 completely redid all their render AOVs. So there's a whole new way of doing render AOVs. You do them nodally now. Now, you used to be able to do, and you actually can still do this if you want to. You just pop up this layers thing here. You can pick your info passes, like an object ID pass, or a light pass maybe, or beauty passes, reflection passes, whatever. That still works. You can click those checkboxes. But you can actually get a lot more flexibility in the schematic. And if you look at my scene here, I've got these little balls. I've got these two area lights, right? And if you look at my schematic, and first of all, I'll do a whole other video on this because it deserves its own video, but just as a base layer, what you can do is, I've got these two different channels now in my render items. This is how it works in MODO. It'll be different in other programs, slightly different, but I've got my render AOV groups, which are my passes, and I've got my AOV output group, which is an ability to composite all these passes together in real time, which is kind of trippy because it's all rendering in real time. So I've got 4 different passes here, right? I've got my 2 light passes, and you can see them down here. I've got light 1 right there, and I've got light 2 right there. I also have an ambient occlusion, which you see here, and I also have a Z depth, which you can see here. And you can, of course, control these things in real time. So I can, change this Z depth here if I want to in real time. And then I have my output AOV group, and this is the composited I guess this is taking my render AOVs, doing some operations on them from these new nodes we have, these new compositing nodes, and seeing the output simultaneously in real time. So what's happening here is I've got this light mixer node, which is pretty handy, and I've got my lights plugged into that. And so one light I'm tinting blue, and one light I'm tinting sort of a pinkish, and I can, for instance, if I want to change this to a warmer color, like a yellow, you can see it here happening in real time. This is compositing, light compositing happening in real time. I can also change the intensity, so I want to bump up that intensity quite a bit on that side. I can do that if I want to. I can also just mix in, for instance, the Z depth to get this sort of black, sort of fading into blackness here. So I've got the Z depth happening. I can change my, I can change the intensity, so I want to bump up that intensity quite a bit on that side. I can do that if I want to. I can also just mix in, for instance, the Z depth to get this sort of black, fading into blackness here. So I've got the Z depth happening. I can change my some variables over here to adjust how I'm bringing in this fog layer. You can see I'm sort of increasing it. There's several ways to do this, but this is just sort of one. I'm sort of increasing this fog amount in real time, which is pretty cool. I'm also bringing in my ambient occlusion layer just to sort of multiply on top of everything. And I just cranked it up to a 1 opacity. You can see that ambient occlusion, that darkness being multiplied on the bottom there. And it's, whoops, that's the beauty. Here's my composited pass. And again, it's all happening in real time. So I go back over to my camera view and I start, altering the camera. I get, not only do I get my beauty pass rendering via the GPU, and I get all these auxiliary passes, my output AOVs, like my lights and my ambient occlusion and my depth channel all rendering at the same time. I also get my composite of all these things rendering at the same time. And so you're really bringing compositing into the rendering app, and it makes sense as you see GPUs get faster and faster. At some point, it's not necessarily going to be faster to render out everything as images and then go to another program and composite it all together the way you start art directing it with the light colors, the intensities, the way you want it. You just do it all in real time. And so the implications of this as we move forward and GPUs get faster, it's pretty amazing, right? Right now, the interface, there's not a ton of compositing nodes. It's not like this is going to replace Nuke or anything. But you see where this is going, and you kind of see what OTOY is thinking about when they're adding these features into Octane 2021. Like I said, it's really pretty startling what you can do. If I pop over to another scene here, let me just pop over to another scene. So here's another example of where this might be useful. I'm going to pop over to a scene that's a forest, right? So it has a bunch of replicated trees, and you see all these bounding boxes are replicated trees. I'm not actually going to turn on show replicators because it'll just suck up a bunch of GPU memory I don't need to give up right now. But the same kind of thing's going on here. If I hit render, it's going to load all that stuff up into the GPU and start rendering. And we've got kind of the same kind of thing going on here. If I go over here to my schematic, I've got a few different outputs. I've got this Z-depth pass rendering. And then I've composited that on top with this AOV. Here I've got my Z-depth over here as a mask to blend in this blue sky color or fog color on top of my trees. And I can control some things with some more nodes in here. Here's like sort of a remapping node. So for instance, I've got a little bit of fog here at the beginning, because if you look at my Z-depth, it's got a little bit of a value here. It's not completely black. It's distant from the camera. So I'm getting a little bit of fog there. But if I don't want that, I could just use my remapping node here to take it out and move that fog back. So I just have it in the distance. If I want a larger effect in the distance, I can sort of bring this down and get a larger effect there and bring it forward a little bit here. And so I'm just doing this compositing in real time. I'm bringing fog into my forest scene in real time. I can even knock out my Z-depth has output has a environmental depth, so I can even knock that out and just get my sky back. And there I've got my nice fog there. Again, it's pretty remarkable. You can kind of see where this is going. It all needs a better interface. Like it's rather clunky, and I'll do a whole new video on this. But you can see we can combine things like this, even with some of the camera effects. Like you'll have your glare and bloom and post processing. These can be separated out into a separate pass. So any pass you can get down here can then be brought into the compositing operations up here and fed into all these different layers. And you can have multiple outputs, of course. These would almost be like multiple After Effects compositions or multiple Nuke compositions. When I saw them doing that, I kind of thought, why are they doing that? Now, when you actually use it and you think, like the next generation or 2 generations of GPUs, it's just all going to be real time. I see where they're going. I see their master plan here, and it makes a lot of sense. One more really useful addition to the AOVs is some custom AOVs. We have access to custom AOVs. So this UV map texture here on our shader ball, I can actually give it a custom AOV. I just pick it from a list here. So I'll call that custom AOV 1. And you can do it on a per object basis as well. So why don't I take my burners down here at the bottom, which is its own object, own mesh, and I can go down to my Octane tab in MODO right here and give this its own custom AOV as well, which is right here. So we'll give that custom AOV 2. Now remember, you got to set this up in the schematic. So if I just go over to my workspace, I've grabbed these 2 AOV channels from the render item here, and I just need to set up my AOVs in the schematic now. So I just get a new render AOV group, and this lets me plug in as many as I want here, or I guess up to 8. And the AOVs I want to plug in are my custom ones. So new render AOV, let's go to custom. And this first one is just custom ones. We'll call it AOV1. I can just control deduplicate that. We'll change this to custom 2. We'll plug that into AOV2. And because this is plugged in here to my render overview group for my render item, they're going to show up down here. So there's my shader ball, and here's my burner. So I can pump out custom mats just for those using custom AOVs. And so obviously that's a super useful thing to do if I need to go into my compositing program later on and adjust, if I just want to isolate those particular materials or items, mesh items, and manipulate them in my compositing program. Lastly, let me just show you something that's kind of weird and maybe a portent of the future. So I can add a node graph into my schematic here. It's an Octane node graph. It'll give me access to all the Octane nodes. And I can hook that up to an Octane geometry pin here in Octane 2021. It's actually an experimental feature right now. So I can hook that up, and then I can edit my node. And so I get this sort of Octane looking window, and I can press space and bring in Octane node. So I'm going to bring in an SDF, a mesh volume SDF geometry. And that's going to ask me for an OBJ file. So I'm going to pick this praying mantis, I'm going to hit OK, and it's going to load it in, and I'm going to plug that into my mesh here, and it's going to show up over here in my viewport, sort of. So this is a signed distance field, which is a different sort of geometry type. I've never been exactly sure what Vectron is, but it's something along those lines. So it seems to me that Vectron has not been exploited yet to its potential, but maybe this is a step in the right direction rather than just creating sort of weird fractal images and stuff like that. So I can go into my mantis here and mess around with it a little bit. So I'm going to take my voxel size from 0.1 down to like 0.025 and hit OK. And now I'm getting a little more resolution here, right? Maybe the wings aren't quite right yet, but his legs are coming in. And this is a pretty complex object. This isn't exactly a cube. But it's weird. It's sort of exciting. Let's try 0.01. And this may be as good as we can get here. Actually, I have no idea how. And now it starts to get... Now we lost something, right? We're getting some little details here, but we're losing something else. So 0.0... Actually, what were we... Actually, 0.1. Maybe 0.1. I think we're at 0.2, so let's try 0.1. Oh, and it must have been 0.01. So, okay, so maybe 0.02 is as good as this goes. I don't really know what the thresholds here are. I'm not really sure I understand exactly what's going on. I do know once you get this geometry inside of MODO, it does not show up in the viewport in MODO. You can rotate it around, and you should be able to change the material as well. And so if I go back to my Octane node graph, I should have material nodes here as well, so I can change the color and everything and do whatever. So it's maybe a glimpse into the future of what an SDF can do and what Vectron can do in your 3D program. Voxelizing complex OBJ objects or mesh objects to a high degree of precision would be cool. And once they're in this sort of, Vectron or SDF format, I think there's a lot you could do with them in terms of Booleaning them. I don't think they take up hardly any RAM at all. And I can imagine this being used for terrain. I can imagine it being used for even things like grasses and hairs and things like that. And maybe even something interesting like this. But, I just thought I'd throw that in as an experimental feature at the end. It's just kind of cool seeing this stuff in MODO and Octane. And it just... And I gotta give OTOY credit. Like, they're clearly thinking of the future. Everything they do seems to be geared towards something that may become more reasonable to do in a couple of years. Now, I've been waiting on Vectron for a couple of years already, it seems like. But this is, clearly going somewhere. Every iteration of Octane, there's some improvement to every existing part of it. And so I really applaud that. And looking forward to seeing what they can do in the future. So there's so much in this release in 2021. There's definitely stuff I'm skipping over, but I need to at least mention color processing because, again, this is OTOY keeping an eye on the future and keeping up to date on things that are important. So they switched to OCIO, or the Open Color IO version 2, which is good. And you have the ability to specify color spaces for textures, which is also super important. The gamma support for textures is gotten bigger, meaning as more sort of data overhead or a sort of larger range of colors can be accessible in the textures by the renderer. So they added the ability to specify the white point for spectral colors, and they have more accurate color processing across the board. So all these things are important. What I see is the industry gravitating towards an ACES, and especially an ACES CG workflow, sort of an ACES CG linear workflow in 3D animation. And that sort of color workflow, it's kind of hard to wrap your head around if you're new to it. Even if you've been rendering for years and you've sort of ignored it, it's a little hard to wrap your head around, and it deserves its own video because there's some setup that's involved, and part of that is a setup that should only be done once, and then there's other things like specifying color spaces for textures. That you can sort of semi-automate that. It's sort of semi-automated in MODO right now, and in Maya and other programs as well. But you need to kind of know why you do it. So I think this is worthy of a whole nother video. And the last thing I want to talk about is volume. So Embergen obviously has a relationship with OTOY, and if you have an enterprise version of Octane, you can get the Embergen betas and alphas that are out right now. I think they're technically in a beta, maybe they're still in alpha, but super usable, super fast. It's kind of mind-blowing actually. And they're obviously putting a lot of effort into volume rendering within Octane. So they've done just a lot of feature improvements here. So you can do light linking for volumes. You have better overlapping on volumes, just sort of nuts and bolts of rendering, right? Better sort of edge handling on volumes. You can see the difference here in 21 and 2022. And you can do sort of instance, there's an ID for volumes, so you can do random color textures and things like that. So again, volumes are going to deserve its own video. The thing I like is they're not just sort of relegating volumes to second-class citizen. They obviously put effort into volumes in every release. And I got to hand it to them. They're not just, throwing in volumes, 2 versions ago and saying, hey, we got volumes now, we're done. They're clearly updating these every single time. So I'm excited to see what Embergen can do with new versions of Octane. This is interesting where this is going.
Yum, yum!